Just start talking. All right, so this is a presentation on the state of Wi-Fi 6 in practice as tested by me and Francois Verges, my co-host of the Clear Descent podcast. And if you do want to see our presentation, you can go to cleartosend.net/mobility Brazil. You can download the PDF there. And what me and Francois were trying to do when we initially started looking into Wi-Fi 6, we really wanted to understand the technology, do it in practice, get the equipment. So we had a specific process that we followed in order for us to test it out and understand it. So the first thing that we did is we tried to understand the theory. And then the second part is we needed to get actual equipment in order to really understand the theory, because if you're like me, I can read theory all day long, but I will never retain it because I can't put it into practice. I can't see it and configure it and understand how it's working. And so, Gustavo, I'll tell you, you can move forward, maybe like 3 slides.
Slides. Okay.
Another one.
Here.
Next one. All right. And then the last thing that we wanted to do was just do some basic tests with Wi-Fi 6. We didn't want to do some elaborate tests and do a whole lecture room with hundreds of devices because one, there isn't enough Wi-Fi 6 devices to test, but we wanted to do some basic tests to get to see if vendors were doing some of the basic features of Wi-Fi 6. So next slide. So this is from WLPC, so you can skip that slide. So there's an animation here which was really funny where we are still in the early stages of Wi-Fi 6, and in this animation, this is a robot from Boston Dynamics. I don't know if you guys are familiar with Boston Dynamics, but they build these really interesting robots that can do things on their own, keep their stability, for example. And in this animation, this robot is handing a Diet Coke over to this guy who's sitting on the couch. But what happens is because these robots are so early stage, when he grabs the soda, the robot hangs onto it. And so he's tugging at the soda and the robot's pulling back. And eventually he gets the soda, but it busts open and it starts like spraying soda everywhere. And then the robot's coming at him still, like thinking he still has the soda. He wants to give it to him. And so part of the with Wi-Fi 6 is that's how it is right now. We're still early. We're going to see features that may not work correctly, or maybe features that the vendor says they support, but then you don't see it in action. And so we're still early stage. We still have to validate. We still have to understand that there's going to be a lot of things that need to be done in the to get to a point where we can have Wi-Fi 6 operational as 802.11ac is, or Wi-Fi 5. Slide. And just to show you how early stage we are, I've been playing with the Cisco Catalyst 9800, and this is not to poke fun of Cisco, but this is because I work with Cisco mostly. I went and got the latest version of their controller, which is 16.12.01, and that was released on August 1st, 2019. Okay, Cisco announced Wi-Fi 6 and allowed you to start looking at their products in April. But if you look at the release notes for 16.12.1 there on the bottom, you'll notice it says Wi-Fi 6 features, OFDMA support for 11AX APs, which means in the beginning, that wasn't even supported yet on those APs. And I was testing the 9800 at 16.10. And so when I was testing it, I was looking for OFDMA. I couldn't see it. I didn't know how to trigger it, for example. And then I see this release note and go, oh, okay. So I spent a lot of time trying to make this work, and it just wasn't working yet because I had the Wi-Fi 6 AP. I have it right here. I just couldn't do it. And I had a Samsung S10, but you had to wait for the release notes and the new code. Next slide. And so here we are with the hype cycle, right? Francois put this presentation in because right now Wi-Fi 6 is at the peak of inflated expectations. There was a lot of expectations for Wi-Fi 6. It was going to solve everyone's problems, right? That's what everyone was saying. It's going to solve all our problems. 2.4 gigahertz is going to come back from the dead and we're going to be able to use it, and everyone's going to be fine and dandy on the existing frequencies that we have available. And I don't know if that's yet the case. I haven't seen it yet. But you can see where 802.11ac is right now, which is kind of at the plateau. That's what we're using. We're hitting the limitations of 11ac, so we're looking towards Wi-Fi 6 for those efficiencies. Next slide. So this was a poll we did at WLPC where we asked people, do they own a Wi-Fi 6 device? And there was a lot of people that raised their hand. And then we asked the next question, how many of you have deployed a Wi-Fi 6 network? And then how many of you have connected to a Wi-Fi 6 network that wasn't yours? And this was just to show that how early Wi-Fi 6 still was. And this was a room just like this one here of Wi-Fi professionals. Next slide. So the first part in going into this, and you can go to the next slide, Gustavo, is the theory of 802.11ax or Wi-Fi 6. So I'm just going to call it Wi-Fi 6 from here on out. Unless I read the the slide and it says 11ax. But when we got started, we had to start with the IEEE draft. And when we were starting to read this, we were reading draft version 3. All right, so draft version 3 was is still early on. And then as we were recording our podcast, we noticed there was a fourth version of that draft. So we really spent a lot of time going through that document. And you can find this on IEEE's website. And if you work for higher education, you may have access to it without having to pay for the document. But this is our source of of all truth, right? This is how Wi-Fi 6 is supposed to work. But the thing with the draft is it's very dry, and you have to read it multiple times unless you're a genius like the guys who work at these vendors here. So we went out to the vendors who are also participating in this IEEE working group, like Aruba, Cisco, Aerohive. And so we downloaded their documents because they were easy to read, and they translated whatever was in the draft into some form of English that we could understand, right? And so these are the resources that we use. We also use the Wireless Broadband Alliance white papers, which were really good in describing how Wi-Fi 6 should be deployed. We still thought it was still early to have some sort of deployment guide, but it was really interesting to read. And you could actually find the Wireless Broadband Alliance white paper on their website. You just have to provide your email address or register. And then also in the Cybex CWNA study guide, there is a chapter dedicated or part that describes Wi-Fi 6, which was done by David Coleman, who works for Aerohive, which is now Extreme Networks. So there's a lot of good documentation out there right now. You can go ahead to the next slide and skip the what did we learn slide. So what did we learn, right? So Wi-Fi 6 is supposed to uh, accommodate all these number of devices that are now joining the network. There's a ton of devices. It's supposed to support different types of mobile devices and their requirements, such as like low power, your IoT devices, or maybe even the devices that require a lot of throughput, such as those VR uh, goggles. And then you need some sort of reliable communications with things like autonomous vehicles. And I will say, like the IoT, we're all seeing I have seen some AR, VR goggles, but only in very specific use cases. And even then, those people were hardwired in on those on those goggles because of the reliability they need that wireless currently isn't giving them. Next slide. All right. So Wi-Fi 6 is supposed to make the protocol, wireless protocol, more efficient. And that's why it is called high efficiency or Wi-Fi 6. So we can go to the next slide. And so in this high efficiency, these are the solutions that it's targeting. So we're going to try to bring back 2.4 gigahertz, make that more efficient. You're going to optimize the channel with the subcarrier sizes. You're going to deal with multi-user communication. So you've got OFDMA, and with OFDMA, you've got multi-user OFDMA, and the same with MIMO. You got multi-user technologies there, and then you're going to push this physics to the limit, right? So now we've introduced 1024 QAM, which includes much higher data rates, and with those higher data rates, then we're going to get the throughput that people are really trying to look for, those numbers that people tout out in their marketing. That's what we're looking for with 1024 Quam. And then there's this idea of scheduling, which can be done with OFDMA and also target wake time. And so we're having the AP now become the central points of communications where it's going to say, here's when you're going to communicate, here's when you're going to communicate. So that way, it decreases the time of contention for all these devices that's trying to get access to the shared medium. And then we're going to do some optimization with the frames, and there's so much. And basically what it boils down to is Wi-Fi is more complex than ever. And especially when me and Francois have read all these documents, it has taken me multiple reads of these documents. And so I'm about ready to take this access point here and go, hey, I want to test it out with the Wi-Fi 6 devices. And it just takes time to really understand it. And I think once you start playing with it, once you start analyzing it, you'll really start to see the benefits. And then we can start comparing Wi-Fi 6 to Wi-Fi 5, Wi-Fi 6 devices on Wi-Fi 6 APs, and also non-Wi-Fi 6 devices on those same APs. We'll start to see more information come out in the future in terms of how Wi-Fi 6 actually works. Next slide. And so here's the draft. All right. Draft version 4. It's 746 pages. Francois and I read tones, MU-MIMO, OFDMA, multi-user MIMO and OFDMA, BSS, 1024 QAM, resource units. It takes a long time to go through. I haven't read every single page. There's a lot of pages with math formulas, and I think Francois is better at formulas than I am, as you'll see in the next couple of slides. But this is all going to be added to the standard, which means the standard is going to be a lot thicker, right? So 746 pages alone of just the 11AX draft. So there's a lot to read. I encourage you guys to actually read it yourselves. It's intimidating at first, but once you start trying to apply some of what you're reading to what you're seeing with vendor equipment, it starts to make a little more sense. So next slide. So here's the timeline. The start of Wi-Fi 6, right? Started in 2014. 2014 when they started talking about this, right? And then they went through some iterations with the draft version because they have to respond to a lot of comments, and then they got to vote on when to move forward. And so now they're aiming for ratification in December of 2020. And I know that date was actually pushed forward because or pushed back because I believe they were aiming for February 2020 at first, and then it got pushed to the end of the year. Next slide. Next slide. All right, so the Wi-Fi Alliance. The Wi-Fi Alliance, their role in this whole thing is to market the Wi-Fi, to market 802.11ax, rebrand it so it makes sense to the normal human beings who are not the superheroes here in this room, to say, all right, Wi-Fi 6 is the new name for 802.11ax. And then you kind of go down the previous generations. Wi-Fi 5 is AC, Wi-Fi 4 is N. And really it's just more coining this term, and they did it in October of 2018. And already I've started hearing clients talk about Wi-Fi 6. It's going to be better, right? Because Wi-Fi 6 is better than 5, which is better than 4. So you just have to understand the marketing with all this and be able to explain some of the technical details and use analogies to help them understand why Wi-Fi 6 would be good for them, right? So these are things you want to uh, consider and be able to answer their questions when they talk about Wi-Fi 6 and how is it different from Wi-Fi 5. Next slide. So with the certification, Wi-Fi Alliance came out with the Wi-Fi 6 certification in September, and they came out with all these graphics. They said, look at Wi-Fi 6 certified the devices, and this is my assumption because when I'm looking at this graphic, I go, okay, so a Wi-Fi 6 certified device must have all these components. Must the device must be capable of doing this, right? So here's another thing to remember with the Wi-Fi Alliance is we have to understand what they're certifying against, because there are going to be scenarios where maybe it's part of uh, a process where they go, all right, we want to look at 3 different vendors and all of their APs must be Wi-Fi 6 certified. because I'll get to the next slide or the next couple of slides. Go ahead, Gustavo, and show you why this matters. But here's what we interpreted from the Wi-Fi Alliance Wi-Fi 6 certification. These are the mandatory things that we saw and then the optional things, right? So BSS coloring is optional, and that's one of the first things I noticed with Wi-Fi 6 access points is that BSS coloring was there. There was a in the frame there was a BSS color, but I felt like that was something easy to put into an AP. But what I would want to test is how the BSS coloring actually works when there's other BSS colors around. And so that's where I thought maybe BSS color would be very highly beneficial for like high dense areas like apartment complexes. Next slide. So did the Wi-Fi Alliance start certifying devices? Next slide. They did. I had to cross this out because back in October 8th, there were 42 devices that were Wi-Fi 6 certified. I checked yesterday, and now we're up to 96. So the Wi-Fi Alliance is rapidly certifying these devices, and that also means there are more devices coming out that are Wi-Fi 6 certified. Next slide. And so if you want to find out if the device you have or the device you're looking at is Wi-Fi 6 certified with the Wi-Fi Alliance, you could go to their website and go to the product finder and put in some vendor details, and you'll get a certificate, little certificate that shows what they're supported. So we'll kind of go quickly through these slides, Gustavo, because it's kind of a sequence of slides that kind of go through it. But if you guys download the presentation, you'll see all this. I just don't want to describe it to you. All right, the equipment. So this is the evolution of Wi-Fi, right? So this is an image that Francois had in one of his training classes where a student came and said, "Hey, look at these Wi-Fi devices I had back in 1999. You know, a PCMCIA card you slide in there. I don't even know what that thing is in the middle. NAP, I'm guessing. I wasn't even doing Wi-Fi in 1999. I think I was still in high school or something. And then you have your access points on the right, your Cisco 9115, and also or I think that's in 17, and then also the Samsung S10. Like so, the evolution of Wi-Fi, things are getting bigger, more powerful. We've got a computer right there on top, sitting on top of that AP. But that's where we are, right? So next slide. When we talk about access points, and you can go to the next slide again, this is kind of the NASCAR deck of vendors who are supporting Wi-Fi 6, right? So you got the consumer devices on the bottom, you've got your vendors at the top. They're all trying to get your support here, and we didn't put Apple here at the time because I think um, Apple didn't come out with the iPhone 11 when we made this slide, and also Apple does not participate. Well, Apple does not publish their Wi-Fi 6 certification from Wi-Fi Alliance. I don't know if they participate and get a certificate, but you also cannot find anything on Apple or their newer devices on the Wi-Fi Alliance website. So they are or they may not be doing Wi-Fi 6 certification. Next slide. So three different terms you have to understand with Wi-Fi Alliance. You've got Wi-Fi 6 compatible devices, Wi-Fi 6 certifiable, and Wi-Fi 6 certified. We all know what Wi-Fi 6 certified means. It means that it is certified for Wi-Fi 6. Certifiable means that the access point supports all of the mandatory features, but it just hasn't been tested with the Wi-Fi Alliance and been given a certificate. And then you have compatible access points where it supports some of the features, but not all of the mandatory ones by the Wi-Fi Alliance, so therefore it's just neither certifiable or certified. And in the very beginning, we had Wi-Fi 6 compatible access points. We just didn't have the requirements at the time when those APs came out. Next slide. So these are the different chipsets that we were able to see that from each vendor, and I think understanding chipsets by each vendor is important when it comes to testing it because there could be some features that are just not possible, and that depends on the chipset and when that chipset came out. And so this is just kind of a growing list. There's blank ones there because we just couldn't find access points at the time that had those chipsets, but it's possible to find these online. So I just wanted to bring this to your attention. So again, going through the Wi-Fi 6 website or Wi-Fi Alliance website, you can find the details. So we can cycle through these slides. client devices. Client devices is a big one, right? Because you can have Wi-Fi 6 access points, but Wi-Fi 6 won't work unless you got Wi-Fi 6 devices, right? So it's not backwards compatible with Wi-Fi 5 and older devices. They just won't be able to benefit from the high efficiency features. But it may be like a byproduct because all the Wi-Fi 6 devices will have the efficiencies, which therefore creates some sort of efficiency for older devices, right? So your Samsung, Apple, Intel, the Intel AX200 and 201, and also some Asus chips devices there that are Wi-Fi 6 capable. Slide. So again, just kind of going through the models that have in a table that may be easier for you guys to see which Wi-Fi 6 certified models. And of course, these are going to just grow, right? This is already an old slide because I didn't update it when I saw 96. I saw 96 devices. Like, there's no way I'm going to fit all that into a table. Next slide. So I have an Intel. So I use both a Mac and an Intel Lenovo T440. I got an Intel AX200 chipset. Got it online for about 20 bucks, 30 bucks, and then installed it on my laptop with updated drivers. And there you go. I have a Wi-Fi 6 compatible or Wi-Fi 6 certified device now. And so with my laptop, I'll easily upgrade it with that little M2 connect or the little chipset, and then you can
Yeah, we
start
do.
testing
By the
Wi-Fi
way,
6.
we have a chipset of this passing here in the room
Oh,
as
there you
we
go.
speak.
Perfect.
So, yeah.
Yeah. So guys, just purchase it. Get if you got a bunch of Intel laptops, just buy a bunch of those chipsets. They're inexpensive. And then you also have the NVIDIA Jetson Nano, which you can install that chipset in. So if you don't want to pay for a $900 laptop or $1,000 laptop, you can get an NVIDIA Jetson Nano and have a Wi-Fi 6 device for under $200. Next slide. You can skip the slide. It's just an enclosure for the Jetson Nano. So the practice. Go ahead and go to the next slide. Just trying to. I know I'm over time. Sorry, went over. So our goal was to test Wi-Fi 6 features. We created very basic tests, and then we basically put an AP. I have a device. I'm sitting fairly close to it, and I wanted to test some of these features out. And we do plan on doing more tests because we have to wait for firmware updates in order to see more of these Wi-Fi 6 features become available. But we wanted to do some of the basic tests just to see, okay, where are these vendors out of the gate when it comes to Wi-Fi 6? Because if you read the websites carefully, it says Wi-Fi 6, here's all the features, right? OFDMA, target wake time, and then you'll find something in small with an asterisk that says feature release. And it goes, okay, I'm buying the access point, it's Wi-Fi 6, but I don't have those features yet. So we want to see what features were possible. And I already mentioned the other one before, which was OFDMA, testing it so early on in April and March, only to find out in August is when OFDMA is actually supported. Next slide. So here's my equipment. I have two Cisco 9115s, a Samsung S10, a Lenovo with the Intel chipset in it, and I just added two Jetson Nanos. Next slide. And I also have an Aruba. I already forget the model number, but I'm using this Aruba Wi-Fi 6 access point as well. I'm actually currently using it at home for my whole house, so my family's on it. And stability-wise, it's working well with Wi-Fi 5. I haven't had any issues. So that's another access point I'll be testing. Next slide. Francois has been testing with the AeroHive AP, the Wi-Fi 6 AP, and if you go to look up some WLPC presentations, we have a presentation in there where he did a demo, and the demo included this AP here. And then the next slide was an ingenious Wi-Fi 6 AP. So we wanted to test out different vendors, compare them, and see, what is the true difference. Is OFDMA scheduling going to be the same across all the vendors? Because if you read the draft, OFDMA, it doesn't tell you how to do the scheduling, what the algorithm should be. And so we predict that each vendor, their secret sauce will be in the scheduling of OFDMA. Next slide. This is the Jetson Nano with a case, and so that there's an Intel Wi-Fi 6 chipset in there, and that is under $200, and it'll run Ubuntu, so you should be able to do captures on that, wireless frame captures. Next slide. All right, next slide. How Wi-Fi 6 operations, right? So I think when everyone talks about Wi-Fi 6, OFDMA is obviously the biggest feature, but Wi-Fi 6 does not mean it's OFDMA. There's going to be times where OFDMA is not going to be used, right? Because if you have one Wi-Fi 6 device and the AP, there's no OFDMA used in that scenario. It's just going to use up the whole OFDM channel. And when I was testing early on, with the Wi-Fi 6 AP, I would do two Wi-Fi 6 devices on that AP, and it just looked like OFDM to me. And so this is why testing is so important because I'm buying into these Wi-Fi 6 access points, but I'm not seeing OFDMA or some of the other features that should be supported right in the from the draft. And so that what we're trying to say here is Wi-Fi 6 doesn't mean OFDMA, even though a lot of people kind of push to say that's the biggest feature. There's multiple efficiencies that are built into the Wi-Fi 6 uh, draft. Next slide. All right, so I'm going to quickly gloss over these because it's a lot of math. This is how Francois came up with his data sheet. And so this is to determine the data rate for OFDM. And I'll let you guys look over these slides on your own time. There's no point in me describing it to you. So next slide. This is the one for OFDMA, the math. Next slide. And that's what you come up with, guys. There's the table for the data rates for OFDMA. This is a new MCS table that Francois created. Francois put a lot of work into this, and I remember when he was telling me about it. And I said, wow, I can't see a lot of those. It's too small. So if you go to the next slide, we'll actually zoom in to maybe the like a 4x4 or a 3x3. And so I was using Francois's table to determine what data rate I was getting. And I was able to find this with the Aruba AP. When I would connect to the Aruba AP and the command line, I can see what data rate the AP is sending and receiving. And so I would get 1024 QAM with my 2x2x2. And so that it's definitely possible to get 1024 QAM. Next slide. So the challenges today is definitely going to be firmware, right? As I've mentioned before, a lot of the chipsets, and it's not really the vendor's fault. I believe it just has to be with the chipset manufacturers because it's so new that you've got the early chipsets, the early adopters, so maybe they don't support all of the features just yet, or maybe it's hard to upgrade some of that firmware. We'll have issues, right? Incompatibilities. We'll have instability. It's just going to happen. I have seen instability with Wi-Fi 6 APs with non-Wi-Fi 6 clients. It's going to happen. You just got to test. And so as you do a new rollout, as you upgrade, just remember to test out these access points before doing a mass rollout. So that way you know what you're getting into, you know what to expect, and you know how to troubleshoot when something arises. Next slide. So our general observations, right? So we got 1024 QAM. We only observed it in 5 gigahertz. I didn't really test 2.4 gigahertz because I'm just used to just using 5 gigahertz to be honest. But the range of 1024 QAM was not that great. So what I did is I had an AP. I went um, to another room, which I believe there was 2 walls between me and the access point, and I did not get 1024 QAM. In the same room, within maybe 6 feet of the AP, I was able to get 1024 QAM. And now this is just with a Cisco AP. It's or with the Aruba AP. So it's going to be different with each vendor. And I'm going to say that hardware does actually matter depending on the how the AP was built. So we are going to see higher data rates as long as we can get up to 1024 QAM. But in the real world, it just might not happen, right? Because of the environments that we're in and how complex some of the environments are. And it's going to fluctuate a lot because when I was testing, I would get 10 like MCS 10 or 11, but then it would change all of a sudden, and I didn't even move my laptop. So we're going to see fluctuations, but that's expected with Wi-Fi. And then we're going to see more efficiencies come out as these vendors put more of these efficiencies in the firmware. And then one thing to consider in infrastructure, these newer APs, you might need more PoE. So never forget that you might have to upgrade your switches in order to get a big PoE budget. And it's just something to remember because I have come into situations where clients plug in their APs, but then there's not enough power for the 3 or 4 APs that they plugged into the switch because the switch just didn't provide enough power. Next slide. All right, next slide. What tools do we use to try to do some sort of analysis, right? So on Mac OS, we use Wi-Fi Explorer to see if it is a Wi-Fi 6 AP. We use Ekahau Pro with the Spectrum analyzer there, using the Sidekick to see whether or not we're getting OFDMA. And then for Windows, you got WinFi Lite and also Ekahau Pro. And then you could also use your AirCheck G2 to also see if there's any Wi-Fi 6 networks around. The other thing I didn't mention was Wireshark. If you're going to do a frame capture, you need to do frame captures with a Wi-Fi 6 device. And the challenge I had with using the Cisco 9115 I have here was I was unable to capture um, uh, Wi-Fi 6 frames. And in the end, months later, I found out it's probably not going to be possible with that AP. We'll have to wait for a newer AP to come out. It's not going to work with the 9115, 9117, and then 9120 for whatever reason. I think it has to do with the chipset. So that's where you can use the Jetson Nano to help you do some of these captures. Next slide. This is just screenshots to show you what Wi-Fi Explorer and all the other applications look like. On the top right, it says Wi-Fi 6 for the network I have. Next slide. Same will show for Wi-Fi. You can see Wi-Fi 6 X-Point. This is all from the beacons. Next slide. So this is the spectrum analysis part, and um, I added Gurman's video that he posted on Twitter here, but because I gave Gustavo a PDF, you don't see the animations there. But on the left, you see just OFDM, and on the right, Gurman was able to what it looks like OFDMA because you actually see three separate OFDM uh, um, like images there, and you could see that they'll differentiate. And I should have just added a link to his little tweet there. But if you look up Gurman's name and then look for that video, you'll see it in action. Next slide.
Yeah, by the way, German will be with us later in the day today. So
Yeah, so he'll probably show it to you. I hope. But Gurman did a lot of great work too. Like, be sure to stay for his presentation. So the packet capture, like I mentioned before, I had a AP in sniffer mode, a Cisco 9115, but unable to capture the Wi-Fi 6 frames that I needed. You could use a Jetson Nano to do that for you. So, see, this is what happens if I don't see all the frames. I see, you see these frames here, but I have a column on the very right called RU, which is the resource units, and this is a trigger frame, and you can see that it's assigning some tones there, but I'm only seeing part of the picture. I don't see everything. So this is where like even our analysis tools are still behind because no one has seen this happen in the real world yet or have developed the tools yet. Next slide. So we can skip a lot of these slides. This slide will help you get your Jetson Nano to do a lot of this analysis. So go ahead and next slide. Keep going. Very technical stuff. All right. Does this change anything with design? Not right now, right? I'm still designing for 20 megahertz, even maybe 40 megahertz channel widths. I'm still doing capacity planning based on Wi-Fi 5, and there's no way that I can, with the tools that I have, design for 1024 QAM. So I'm still doing the same design methodologies that I know for Wi-Fi 5 and applying it to anything that has to do with Wi-Fi 6. And hopefully with newer versions of like Ekahau, for example, coming out, they'll have some of those calculations like BSS coloring built in. They'll have capacity planning built in because a lot of these just isn't in any of the applications we use yet. And so I wouldn't focus so much on trying to design for Wi-Fi 6 because one, we don't know how Wi-Fi 6 is actually going to affect our capacity for wireless networks just yet. And there's still a lot of features that are missing. So keep designing the way you've been taught to design for capacity, and just try to minimize contention. And we will wait until we're fully in the Wi-Fi 6 cycle here. So next slide. Should you upgrade your infrastructure to Wi-Fi 6? Not without testing. All right. So if you're in a cycle where you need to test or you need to upgrade, be sure to test it first. I've run into two scenarios where a client just upgraded all of their APs to Wi-Fi 6, and then they told me they had issues. And I go in, I go, what changed between the time you have issues now and before? And like, oh, we upgraded to the latest and greatest Wi-Fi. I said, why? Like, it was working before. Why did you change? And he goes, because it's the latest and greatest. And so it's fine to be, on the bleeding edge, but you have to be smart about it and test it out. Test it out with your devices. Test it out with your environment before rolling it out completely. So there's a lot of first generation access points that are probably not going to be sufficient, and so newer access points are coming out now. Test it, and then I'm noticing that there's a lot of 6 gigahertz talk, and these APs just don't support 6 gigahertz from what I see on the FCC filing for these APs. And so that's also coming down the pipeline, which will dramatically change Wi-Fi 6. Next slide. So we went through a demo, so I can't do the demo. This is a photo of Francois trying to set up the demo, ran into some hiccups. We broke a Mist lab, and this is what the demo looked like when we were trying to get Wi-Fi 6 clients to join the AP. And we had an iPerf server, so people were able to do an iPerf test, right? And so that's what we set up in the room. People were able to connect, download, and we saw Spectrum, but we just didn't see OFDMA. And this was with the Arrowhive AP. Slide. And then we had a party afterwards. So I had a Wi-Fi 6 party. So we and Gurman was there. We were all trying to figure out, can we get OFDMA? And I think it turned out that none of the devices we had supported OFDMA. So we spent a lot of time just actually getting to know each other, playing around with Wi-Fi capturing. So it was a very good time. Next slide. Acknowledgements to the people that we've communicated with. A lot of these guys are actually smarter than we are when it comes to Wi-Fi 6. And a lot of these guys helped us in acquiring some equipment to test it and validate some of our theories. And so thanks to them. Next slide. And that's it. So you can download the presentation. We have a series on Wi-Fi 6 on our podcast. If you guys have any questions, feel free to contact me on Twitter or via email. It's at Rowell Dionicio on Twitter. And hopefully I'll be seeing what you guys have to present on Wi-Fi 6. I know a lot of you guys will probably be working on really great projects. So I'm looking forward to seeing what you have. Stay tuned for Gurman's presentation because that is going to be awesome as well. And guys, you're taking the best step right now, and it's participating in events like this. This is what really increases your knowledge. It gets you into a closer, tight-knit community where we share what we have, right? We share what our experiences and we share what tips we can give to other people who may be having a challenge in their environment. So I want to give an applause to you guys for participating and thank you for having me here for Mobility Brazil.
Thank you. Thanks, Rowell. Excellent presentation. Thanks. Just a sec, Rowell, if you can stay for a sec.
Yeah.
Hey, hi, can you hear me?
Hello.
Yeah. Presentation, very comprehensive, right? A lot of
Thank you.
tests. I'd like to ask you if you got the chance to test the Wi-Fi 6 working with the other technologies like AC or the others, because we know that earlier when testing, let's say 11G with B, right? We had some problems, right? We had to lower the speeds and so on. And so that's pretty much the question, right? Testing the Wi-Fi 6 with other technologies.
So I have had some exposure to AC with Wi-Fi 6 access points, and in the enterprise environments I was in, we were seeing weird issues where video-based applications were kind of dropping for whatever reason, and I could not figure out why. I ruled out absolutely everything. all the way down to I ended up basically going down to the hardware level and going, all right, I ruled out design, capacity, anything else that I could find. And what ended up happening is they swapped it out for an 11 AC access point, they saw way better performance. Same thing with another environment. They were getting they had mostly 11 AC devices, MacBook Pros, and they were getting weird connectivity issues where they would drop. They would try to get DHCP, but it wouldn't work. And I rolled out everything there. I even made their network better because they didn't have a design. I turned off a lot of APs, and that still didn't do anything. And they ended up swapping it out for 11 AC APs, and everything went fine. I'm testing an Aruba AP here in my house, only because my kids, my wife, they use 11 AC devices, and if something's broken, I'm gonna hear about it right away. And so far, I haven't had any issues with 11 AC devices, including some of those IoT devices like your Alexas and your Google Homes, and I haven't had problems there. So I have been using my 11 AC devices with a Wi-Fi 6 access point, but only in a home environment, and I haven't had problems. But yeah, there's still going to be some issues, and I think it's more chipset related than vendor related.
Thank you.
Okay, Rowell. So thanks again for your time. So your guys' work, you and Francois, and Clear to Send is also awesome. Thanks for the
Thank you.
presentation. It was really good. Thanks. Thanks for your time. And for sure, the community appreciates your participation.
Yeah,
Thanks
thank you
again.
guys for allowing me to present. Thank you.
Thanks, Rowell.
Thanks.
Have a
Thanks.
good event.
Valeu, valeu.